All right, let's start this. I hope, please. Yeah. Okay. So it's part 5, and get used to these. A lot more coming your way. You can thank the New York State test for that. Don't blame me. All right, so they're all multiple choice. A big part of your test is multiple choice. So might as well get used to it. So number one, at noon on Monday in Minneapolis, the temperature in degrees Fahrenheit was -4. At noon on Tuesday, the temperature was 6 degrees higher. What was the temperature on noon? At noon on Tuesday, well, it won't hurt for you to do something like this. So you're at -4, right? And it says it went up, so you got warmer. So it went up by 6, so you can just simply do 1, 2, 3, 4, 5, 6, and you can add -3, -2, that's -1, that's 0, that's 1, and your temperature is 2 degrees. So I'm going to do it, I guess, left to right. What is the value of the expression here? So we're going to take care of the absolute value first, and we're going to leave everything alone. Plus the absolute value of -4 is just 4, because -4 is 4 units away from 0. So let's change this, change that to 4. I'm going to then change 3 squared to 9, right, because it's 3 times 3. And the rest is just a matter of adding. So it's 15. Clear, clear, clear. There we go. Let me lower it so I can do 2, 5. All right, so 2, what is a binomial? Binomial is an expression that has 2 terms. Remember that expressions, right, in an expression, terms are separated by an addition sign or a comma. So think of them as your commas, right? So PW is just a monomial because it's made up of one term. 3W also is made up of one term. 3W plus 1, well, there's one term and there is an addition sign. So think of it as 3W in a way, comma 1. So we have 2 terms here. So that is a binomial. And a binomial, obviously, think of by the prefix by, bicycle, 2 wheels. What else starts with by? No, I don't know. Right? It's two terms. Definitely not this one because this has 3p squared, comma 2p, comma 2. So this is made up of 3 parts or terms, and we're looking for something that has 2 terms, and our answer is C. Find the value of a in the equation below. This doesn't look an equation, so whoever wrote this should have written expression. And we're gonna skip this because none of these answers, are correct. So the one thing, if they had said, was simplify the expression, which would be combine the like terms, so we would have been able to add this and the plus a, 3a plus a. Remember, there's a 1 here, so that would have given 4a. We can add the plus 2 and the plus 6, and that would have given us plus 8. So the expression simplified would have been plus 4a plus a. So none of these are actually correct. 3 and 6, a box contains 6 red pens and 4 blue pens, so there's a total of 10 pens total, right? Corey randomly picks a pen from the box and keeps it. Then Tom randomly picks a pen from the box. What's the probability both keys what's the probability both boys will pick a red pen? Well, so first guy goes in, so the probability of taking, we want to get a red pen and another red pen. Remember, we're not putting the pen back once it's taken. So Corey is going to go, the probability of taking a red pen right away in the beginning, there is how many red pens? So he has a 6 out of 10 chance. I'm going to multiply that. And then let me write this 6, and then there's 4 blue. So Corey goes inside here, picks a red pen, puts it on the side, goes back. Once he goes back, there is no more 6. There are 5 red pens. So now it's Todd's turn. He goes into the box and he randomly selects one, and hopefully he picks a red. So the probability of him selecting a red now, it's 5 because 1 was taken, so 5. And our total change, there's not 9, not 10 anymore, but there are 9 pence now. We can simplify this, right, before we multiply if we can. This and this can simplify to half. This can simplify to 2/3, and our answer is 2/6. We have 2/6? No, we don't. Did I do something wrong? Oh, 2/6, which simplifies to 1/3. I could have also simplified these two. So final answer 1/3. A. 6. Joan flipped a coin 100 times during a math experiment. The coin landed on tails 36 times. Based on Joan's result, which of these statements is true? The coin landed on tails more than expected. Well, if you flip a coin 100 times, theoretically, you would expect it to land on 50 times on tails and 50 times on head. That would be your expectation. So the coin landed on tails more than expected? Not true. We were expecting 50. The coin landed on heads less than expected. If he landed, so on our experiment, if he landed on tails 36, so 36 of them was tails, which means the remaining 64 wasn't heads. So during the experiment, this is what happened. This is what we expected, right? And this was what happened on the experiment. So the coin landed on heads less than expected? No. The coin, actually, we were expecting 50, and it landed on heads 64 times. So that's also not true. The coin landed on heads more than tails. That is definitely true. In the experiment, the coin landed on heads 64 times and on tails 36. So this one is correct. I'm not even going to bother reading the other one. So final answer C. 7. Helen's preparing candies for bags for the children at her party. She has 2 flavors of lollipop, 4 types of candy, and 6 flavors of chewing candy. So 2 lollipops, 4 candy, and 6 chewy. Each bag contains 1 piece of each kind of candy. What is the total number of possible candy combinations for the bag? So you can, and this one goes to that fundamental counting principle. So our first option, so we have 3 options here. So we have option 1, which is the 2 lollipops. Now on the second option, we have 4 candy bars. And the last one, we have 6 chewy something candy, right? So remember, if we made a tree diagram, it'd be, and let's just say the lollipops were different, right? So it'd be lolly 1, lolly 2, and with that lolly you can have 4 candies. And then with each candy here, you can have 6 different chewies. 1, 2, 3, 4, 5, 6, right? So instead of doing a tree diagram and counting everything, all the different possibilities, one thing you can do, well, you know there are 2 choices here. There are 4 choices over here. And there's 6 choices over here. So 2 times 4 is 8. 8 times 6 is 48. So you can have actually 48 different candy combinations. Okay. Number 10, Brenda wants to conduct a survey as to whether mushrooms should be added to pizzas sold in the school cafeteria. Which sampling method will offer Brenda the best results? So if you were to conduct a survey and ask people, hey, should we add mushrooms to pizza, who would you ask? Where would you get the best result? What group of people should you ask to get a fair result? Should we ask all the vegetarians? Well, that doesn't make sense, because if you ask all the vegetarians, they're going to say yes, put mushrooms. So that you don't want to only ask them, so that's out. Interview every student at a pizza parlor. Well, if you interview people who are in a pizza place to begin with, it is highly likely that they might say yes to that too. So that's biased, right? Not really fair to ask only people who are at a pizza shop. So that's gone. That's not fair. Interview every student who brings lunch from home. Well, if you're bringing lunch from home, it probably means that you don't like fast food. Okay, you probably lean more to the home cooking. So again, not biased, because these kids will probably say, no, I don't really want mushrooms. I eat lunch at home. I don't care. So not the group of people you want to ask. And the last one, interview every student who eats lunch at the cafeteria. That makes the most sense because they're the one who are going to be eating the lunch anyways. That's the group of people you want to interview. 8. Rosie, Randy spins the spinner. And the arrow on the spinner was 5 equal sections. So there's A, B, C, D, E. Right, there's 5 sections on the spinner. Then he rolls a 6-sided cube. So there's a cube here, a number, right? So there's 1, 2, whatever, all the other numbers on the other side. And 1 through 6, what's the probability that the arrow will stop on the letter A? So he wants to get A, and then what does he want? And the number 4. So what's the probability both of them will happen? Well, the probability of landing on A is 1 out of 5. Times the probability of landing on 4, it's 1 out of 4. So if you multiply these two, you get 1 out of 20. So there's a 1/20th chance of this happening, which is definitely not here. And what am I doing wrong? Oh, that's because the die has 6 sides, not 4 sides. So probability of landing on A is 1 over 5, so that's correct, times the probability of landing on 4 is 1 out of 6, and this should be 1 out of 30. 11. For the lunch special at Nick's Deli, customers can create their own sandwich by selecting one type of bread and one type of meat from the selection below. In the sample space below, list all the possible sandwich combinations using one type of bread and one type of meat. If Nick decides to add whole wheat bread as another bread option, how many possible sandwich combinations will there be? So I'm going to do a treat. Well, I'm going to do a list. So what can I get? I can get the white bread. I can get white bread with chicken. So I'm going to write. I'm not going to write like that. I'm going to get white bread with chicken. I can get white bread with roast beef. I can get rye bread with chicken, and I can get rye bread with roast beef. Or not. So based on this only, I can get 4 different types of sandwiches. Okay. Now, if you add rye bread, if you add whole wheat bread, so let me pretend there was another category here, whole wheat. How many different sandwich can I make now? But that's not that hard. So with whole wheat, let me just write WH for whole wheat and chicken, and I can get whole wheat and roast beef. So now I can have 6 different types. So if you use the fundamental counting principle, how many choices of bread do we have? 3. How many choices of meat do we have? 2. So that gives us 6 different combinations. Number 9, a scientist discovers a dinosaur bone that is 7 times 10 to the 7 years old. What is the number standing for? Okay, so this is okay, second grade thing. So we're changing this from exponential scientific notation, or just exponential form, and changing to our regular number. So 7 times in 10 to the 7 has 7 zeros. 1, 2, 3, 4, 5, 6, 7. If you multiply that out, you get this. 5, 6, 7, and that is going to be 70 million. C. A museum opened at 8 in the first 350 something. In the first hour, 350 people purchased tickets. Okay. In the second hour, 20 more people purchased. So let me write this. At 8 a.m., there were 350 people. Right, that first hour. And then in the second hour, starting at 9 a.m., so from 8 a.m. to like 9 a.m., 350 people showed up. So starting at 9 a.m. and fourth, 20% more came. So what is 20% of 350? So let's find out. 350 times 20%, which is 0.2. And that's going to give us 75. you had 20% more people. So if you had 350 people in the first hour, in the second hour you had the same amount, 350 plus a little bit more, 75 people. So you had a total of 425 people in the second hour. So from 8 a.m., no, just right, 8 a.m. to 9 a.m., you had 350 people. But from 9 a.m. to whatever, the second hour, to 10 a.m., there was 20% more, which means 350% plus 20% of that, which is 350 plus 75. You get 425 people showed up in this time period. Each admission was $17.50. So what was the total amount of money paid for all the tickets? Well, $350. You multiply this by $17.50. Everybody pays $17.50. The second hour, 425 people show up, and you multiply that by $17.50. So 350 times 17.5. Over here, you had $6,125. In the second hour, more people showed up, I guess, because they woke up, right? 17 times 5. They made 7,437.5. So they want the total in both hours. So if we add those two, they made a total of $13,562.50. Not bad for 2 hours of work. 13, triangle. Okay, so yuck. So one good thing is that you're going to have a calculator. So even if you see something like number 16, you shouldn't really be too scared. So let's do 13 first. The 13 says that it has a triangle. Right, so I don't know what kind of triangle. I'm just going to draw. And this one is 5.5x plus 6.2y. And this side is 4.3x plus 8.3z. And the last one is 1.6z minus 5.y. So what I can do here is combine all the like terms. I'm going to pick all the x's first. So it's 5.5x and 4.3x. Those two are the same. So I'm going to add those two, right, because they're both plus. So 5.5x plus 4.3x equals 9.8x. Or anything with 9.8x? Yes. C and D. So right away I can throw this in the garbage, throw that in the garbage. So now it's between those two. Let me choose a different color, and I'm going to do the y. So I have plus, so that's positive 6.2y, and there's another y, yeah. But this is a minus 5.1y, so we're going to have to subtract these two. So y comes down, 2 minus 1 is 1, and 6 minus 5 is 1. So that's going to be, that looks like multiplication. That should be 1.1y, so positive, by the way. So plus 1.1y. Any of these two answers have 1.1y? Yes. This is automatic garbage. The beauty about multiple choice, one of them is an answer. Here, again, you can use your calculator. So it's -7 over 10. So I am just going to change this to 0.7 just to make my life easier. I want to deal with fractions. So -0.7 plus, is that plus? Plus 0.15. That's going to give me, so I'm going to write this over here. That's -0.55 divided by -0.125. I know a negative divided by a negative is a positive, so now I just got to divide 0.55 divided by 0.125, and that's going to give us 4.4 positive. So, okay, so that's it. So, C. $17, let's do 17. During a sale, a store offered 40% discount on a particular camera that was originally priced $450. After the sale, the discount price of the camera was increased by $400. So here is your camera. The price went down because it had a discount, and then it went up. So what's the final price here? Well, the first discount was 40%. So let's find out what 40%. So the 450 times 0.40. I'll just do it the long way. So 450 times 0.4 equals 180. So the discount was 180. So if you subtract 450 and take away 180, you're going to have that the camera now it's $270 because it went down 40%. Now after the sale, it went back up by 40%. So the camera is now $270, right? So we want to increase the price by 40%. So let's find out what 40% of 270 is. Multiply those two. 270 times 0.4 equals 108. So we're going to increase the price by $108. So here's the price of camera after the discount, right? 270. Let's increase it by 108. If you increase it by 108, your final price now is 378. So we're gonna raise the price up and we're gonna put it as 378. Where am I? 14. Ugh, yuck. All right, so I would change this just to make my life easier. Okay, and I can because the decimal, I mean the fractions on nights is at 2, right? So 7, if you took the calculator and divided 7 divided by 2, you get 3.5. So I'm going to rewrite the expression like this. 3.5 h minus 3, 5h, and instead of a half, I'm going to write 0.5. I don't have to deal with fractions, okay, when I can. So now we got to do the distributive property, right? So it's 3.5h. Let's multiply these two. Negative times positive is a negative, and I get 15h. Negative times this negative over here is going to give me a positive. And 3 times a half, oops, hang on a second, just knock the cable out. It's going to be 1.5, and that's 1.5 positive. Combine like terms, I can combine these two, but I can't combine the 1.5 because that doesn't have a variable. So 3.5 minus, oops, this should be 1.5. 3.5 minus 1.5 is 2h plus 1.5. And is there anything that, what in heavens is going on? Oh, that was 15. Sorry. I thought that I messed up here. Uh-oh. What just happened? No, seriously, what just happened? I don't know what happened. So, I need that program to come back up. No. Close. Go like this. Okay, so again, I'm going to have to do it again. 7 over 2 is 3.5h minus 3, 5h minus 0.5. So 3.5h stays because that's not being multiplied. It's not here in front of the parentheses. Negative 3 times 5 is negative 15h. And negative times a negative is a positive, which is going to give us 1.5. Now, I can't. So the one thing you can do, you know you're going to be adding these two, right? Combining, sorry, these two. And the last part of your expression is 1.5. 1.5, another positive 1.5 plus 1.5. And positive 1.5 is the same thing as 3 over 2. So just by looking at this plus, I know this guy is not it. And this guy is not it because that has a minus sign. So garbage, garbage. Now, I have to figure this out. So it's going to be plus 1.5, right? Because the same thing as 3 over 2. And then this is 3.5h minus 15h. 3.5h minus 3, okay, minus 15h is 3.5, 12, 11.5h, but negative, right? If you think about it, who's going to win? You have 3.5h minus 15h. So 3.5h plus, right? I'm going to change this to an addition and the additive inverse, which is negative 15h. So you definitely know there's more negatives, and how many more negatives? 11.5. So you know that the answer has to be this one, right? Because it's a minus 11.5, which is the same thing. If you took on your calculator and you divide 23 divided by 2, you get 11.5. So this is the same thing as negative 11.5 plus 1.5, and again 3 divided by 2 is the same thing as 1.5. Where am I? 15. Yesterday the temperature was 11.4. So you were here, 11.4 positive, and then it went down by 15.7, and it went down. So you're going down 15.7. Where are you now? Where is the temperature now? So you definitely know that it's colder, right? So you can go 11.4, which is your starting point. Going down means negative, and by how much? 15.7. So if you can, welcome to do that on your calculator as it is, and take advantage of that. 11.4 minus 15.7, you should get negative 4.3. And here we are. And it makes sense, right? Okay, it really makes sense. So think about it. I don't know, think about it as an apartment. If you're on the 11th floor, and I'm just rounding that, and you go down 15 floors, obviously you're going to pass the 0th floor, and you're going to pass the 0th floor, and you're not going to go too much after that. So these numbers really don't make sense, right? The only one that sounds reasonable is that one. Just 18. The table shows the prices of different number of cards on the website. Number of cards, okay. For each order, the website applies a 7.7% sales tax to the price of the cards, plus a one-time mailing fee of $5.95. Based on the information on the table, how much will it cost for an order of 208 cards? Well, hopefully they're proportional. So let's take a look at the first one. $13. I buy 20 cards. And let's find the unit rate. So if I divide this by 20, right? And divide this by 20, so I can divide 13 divided by 20, and that's going to give me 65 cents. And I'm going to write at the bottom because I don't know. 65 cents for one card. Okay. So how many cards are we buying? 280. So let's calculate. So 280 times 0.65, that's the price of one card. Let's find out how much that is first. 280 times 0.65. 280 cards is going to cost us $182. We're not done because now we got to pay 7.7% tax. So 182 times 0.077. Let's find out how much the tax is. Times 0.077, and we're going to pay a tax of $14.01. So now we got to add those two. $182, 14.01, and I'm going to pay $196.01 for the cards plus a tax, but I also have to pay a mailing fee of $5 for the stamp or for the postage, right? Shipping fee of $5.95. It's a one-time only. So that's a 6, that's a 9, that's 11, that's a 0. I end up paying $201.96. And then, how many more? Oh, 3 more, that's it. Which problem represents the probability of an event that is very likely to represent? So remember, we can represent, so this is impossible. And this is certain, right? So this could be 100%, not could be, it is. This is 0%. As a fraction, that's 0, and that's 1. As a decimal, or so that's a half, right? So something that's very likely to occur. Well, they want it as a decimal, so let me change this. And let me write 0.5, which is the same thing as 50%. Yeah. So we're looking at here, right? Because it's not in percent form. 0.12 would be around here. So let me just add here, so make it easier. 0.50, 0.12 would be here. 1.3 would be over here, and that's gone, right? Because it can't pass 1. It's anywhere between 0 and 1. It's never going to be outside that. 0.12 is gone because it's not very likely to occur. 0.09, it's even worse. It's over here. That's also not likely. And 0.89, it's 89%. So this one is the one we're looking for. Spinner, board game, equal size, a bunch of sections. There's a number between 1 and 5. Which number is a reasonable estimate for the number of times the spinner will land on a section labeled 5 over the course on a section? Okay, so what's the probability landing on 5 if you're going to spin this 150 times? Well, how many sections are we talking about? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's 12 sections. Probability of landing on 5. How many 5s are there? There's 1, 2, 3. Probability of landing on 5 is 3 over 12. And if you simplify that, you get 1/4. So there's a 1/4 chance that if you spin this, it lands on 5. Good. Now, so our prediction, we want to predict, right? So we're going to take that probability, 1/4, and multiply it by how many? 150. So if you were to spin that 150 times, how many times would it land on 4? Oops. Which is 37.5. And so the answer in the calculator comes 37.5. Obviously, you can't have 37.5 spins. So they're rounding this, right? It's an estimate, first of all, so it's not going to be a precise answer. So the closest one to 37.5 is C40. 20. Casey rolls a fair number cube with 6 faces numbered 1 through 6. She rolls a number cube 600 times. Which result is most likely? So we'll roll a 1 or 2 50 times. So what's the probability landing on 1 or 2? Well, you have a 2/6 probability, right? 2 over 6. If you multiply that by 300, right? So think about that. It's going to be, let's see, 650, 100 times. So that's gone. You would expect it to land on 1 or 2 100 times. So this said 50, so it's wrong. Casey will roll a 1 or 2 exactly 50 times. That's also wrong because we just said that's should be 50 times, not 100. Casey will roll an even number about 150 times. Well, if you have, what's the probability of landing on even? 3/6, right? Or half. And if you were to do this 300 times, it'd be a half, right? Times 300, which is 150. That makes sense. Let's just look at the last one. So this is garbage. That's garbage. Casey will roll an even number exactly. Casey will roll an even exactly 150 times. So the difference between this one is this word, exactly and about. Casey will roll an even number exactly 150 times. It's not going to be exact. We're expecting 150, so it should be this one. Let's see. That word kind of ruined everything for letter D. Okay. And am I done? No, yes. Yes, yes. Okay, that was easy. Okay, that was part 5. And you're done.